Here are the representatives of 8 modern avian orders and 8 modern avian families. If one were to ask which of these avian orders includes fossils which are known from the Precambrian period, this is 4 billion out of Earth's 4.5 billion years in history. The answer is none. None of these orders date to the Precambrian. Which of these orders date to the Paleozoic era of the Phanerozoic eon? This time period represents the first 250 million years of vertebrate history. The answer is none. None of these bird orders, in fact no birds at all, are known from the Paleozoic era. Which of these bird orders include fossils known from the Mesozoic era? Well, none from the Triassic period. The first birds date from the Jurassic period, but the first birds are not in any of these modern bird orders. They were quite different. And it is possible that a few modern bird orders date to the very end of the Cretaceous period, just before the mass extinction. But these fossils are fragmentary. So for example, order Anseriformes might date to the end of the Mesozoic era. Although fossils of birds from the end of the Cretaceous are fragmentary, it seems as if there was some diversification of the lineages alive today just before the mass extinction. After the mass extinction, when 60% of life was wiped out, birds underwent a very rapid radiation, filling in a number of the empty ecological niches now that the world was so changed. A number of modern orders originate from the Paleocene epoch, right after the mass extinction, including that of rheas and herons and hawks and eagles. And the others represented here all are known from the next epoch, the Eocene epoch, including the order which includes doves, turkeys, woodpeckers, and the songbirds, which make up the majority of birds alive today. When did modern avian families originate? Well, each of these images begins in the time period of the Cenozoic era, which we divide into epochs, in which the order originated. But as far as modern families, some include fossils which date to the Oligocene epoch, 34 to 23 million years ago, and that would be the duck family Anatidae, the turkey family Phasianidae, the heron family Ardeidae, the woodpecker family Picadae, and the hawk and eagle family Accipitridae. Some families date from the Miocene, which would include the family Columbidae, which includes doves, and the family Corvidae, which includes crows and jays. The family which includes modern rheas is not known in the fossil record prior to the Pliocene. So thus one can see that modern bird groups were absent from most of Earth's history, including most of the history of birds, and modern families have arisen only recently in geologic history. There is another way to try to estimate the age of divergence of certain groups, and that is to use comparisons of genetic sequences, what is known as a molecular clock. With this idea, the more differences which have accumulated between two lineages, the older that they are. Now, this is certainly very useful since the fossil record can be limited. So, for example, one part of the world might not have very many fossils from a certain time period, which is when a certain group was originating. And so this is certainly useful. It needs to be calibrated often by events in the fossil record which can be definitely dated, such as a mass extinction or the splitting of continents, etc. Two major problems which arise is that the rate of genetic change can be compared only if two different lineages are experiencing the same level of natural selection. If one group is kind of staying the way they were, and one group is modifying very quickly to a new ecological niche, then changes accumulate in one lineage faster than normal. So this needs to try to be taken into account. And one of the things which is extremely problematic is, for example, in birds, right after the mass extinction at the end of the Mesozoic era, there was a huge radiation of life, not just of birds, to fill the empty Earth's niches. Lots of things were changing very, very quickly, much more quickly than normal. And so it is very hard for a molecular clock to accurately identify the timing of branch points if so many branch points occurred in a narrow space in time. Nevertheless, many biologists will refer to molecular clock comparisons to try to gauge when different groups of birds originated or split from other lineages.